So far we've looked at transformations using matrices. There's one type of transformation or change to an equation that we haven't looked at just yet. That's finding the inverse. So let's just start with a generic linear graph. So y equals 2x plus 3, and we remember from previous chapters, to find the inverse we swap the x and y. So when x equals y, so we write this as x equals 2y plus 3, and then rearrange to get y as a subject. So x minus 3 all on 2 would be the equation of the inverse. If you want to use matrices to swap the x and y, or reflect in the line y equals x, we can use the matrix 0, 1, 1, 0. And we'll notice when we times that by the matrix xy, we end up getting 0x plus y, and then we get 1x plus 0y, and that will equal to the image of our new graph. And what happens is then the top part of this left hand matrix, which 0x will be 0, we end up getting y, and x down the bottom, we find that the image of x is now y, and the image of y is x. So all we've done is we've swapped x and y. So if you want to reflect a function in y equals x, then we can multiply it by the matrix 0, 1, 1, 0. And let's look at a couple of examples where this reflection is occurring alongside some other transformations. Alright, let's look at question 3 first. So we've got transformation matrix is 0 to negative 3, 0, and find the equation of y equals 2x plus 3 under this transformation. So if we put in our x, y values and set that to the image, then let's expand this bracket out. So let's go first row by first column. We get 0x plus 2y equals the image for x, and then negative 3x plus 0y equals the image for y. So you'll notice what actually happens is we now have an image for x that's only got a y in it, and we've got a image for y that has an x in it. So the x and y's are going to swap. So there's actually a reflection in the xy axes. So that diagonal sort of flipping there. So here's our original equation. We want to get it in terms of x and y. So this one, for our image of x, we divide the 2 across. We get y equals the image of x over 2, and x equals the image of y over negative 3. And then we sub that back into the original equation. So what colour have I used? Let's go red. So y, I'm going to put in x on 2. And up here where the x is, I'm going to put in all this stuff here. So 2 times negative y on 3 plus 3. And now I've got to get it to look like a standard equation. So let's try and get the y by itself. So I'd have x on 2. I'm just losing the image notation here. Minus 3 equals 2 times negative y on 3. And then divide 3 by 2, I'd have x on 4 minus 3 on 2 equals negative y on 3. So then I have to multiply by negative 3. Oh yuck, this is a fun one. Alright, so I'm just putting the y on the other side of the equation here. I'm multiplying both sides by negative 3, but I just want it to look nice and neat. So that's why I've swapped the sides. So timesing both sides by negative 3, I would get negative 3x on 4, and that would become plus 9 on 2. That's our final equation. That's a nice and fun one there. Okay, let's look at exercise 7H, question 5. Now, this question has a matrix equation that's got a transformation matrix which has got dilations and reflections in the x and y, as well as a translation matrix B. So this is the information from the question written down here on the left of the screen. We've got the transformation matrix outside here is multiplying the original matrix, and that represents this equation here, y equals negative 2x plus 6. And you can see inside the brackets we're plussing B and then all of that equals the new image for x, or the new equation. And the question is asking us to find the equation of this straight line once it's undergone those transformations. So let's, just like every other question, let's write our matrix equation first. So t is 0, negative 2, 1, 0, and then that is multiplying our xy, and that is being plus by our b, which is negative 1, 2. And all of that junk is going to equal your image. Now, this is a super long question, so bear with me. We've got brackets, so we're going to solve this brackets first. So that would give us the matrix x minus 1, y plus 2. And then we're going to be multiplying that by that transformation matrix. Now, you could use your CAS for this. I probably should use my CAS, but let's do it this way by hand. So again, let's multiply these through, first row by first column. So we'd have 0 times x minus 1, and then minus 2 times y plus 2, and all of that is going to equal the image for x. And then the second one, second row by first column, I'd have 1 times x minus 1 plus 0 times y plus 2 is equal to the image of y. If I tidy these up a bit, zeros cancel off. 0 times anything is going to be 0. So I have minus 2y minus 4 equals the image of x. And this would be x minus 1 equals the image of y. Now let's try and get these in terms of x and y by themselves. So let's write our two equations. So let's take this one out, and we'd have a negative. So we've got, let's get divide by negative 2. So I get y plus 2 equals, over here, negative x dash on 2. And then we can minus the 2 over. So I'd get negative x dash on 2 minus 2. So that's my new y value. And then my x value. And I'm going to square that because we're going to sub that into the final equation at the end. And the x value would be x equals y dash plus 1. That was nice and easy at least. And so now we want to sub these into the original, or the OG equation, which was, and I've forgotten it, to the top there. So y equals negative 2x plus 6 is our original, and we're taking these two new values for x and y. So y is all this fun stuff over here, so it's negative x dash on 2 minus 2, and then the x value is y dash plus 1, so I'm going to have negative 2 y dash plus 1 plus 6. And now it's a matter of tidying this up to get it into the standard form where y is the subject. So let's minus the 6 over. I'd get negative x dash on 2 minus 6 is minus 8. And over here I've got minus 2 y dash plus 1 still. And so then let's divide through by the minus 2. And we'd get that, make this negative 2, if I divide that, make that a positive quarter, so that's x dash on 4. Negative 8 divided by negative 2 is positive 4. And then we've got y dash minus 1. So then y dash must be x dash on 4 plus 3. So the new equation is y equals x on 4 plus 3. And that's question 5. You can breathe a sigh of relief.